Hey Finxters, what's up? It's Chris, founder of Finxter.com, and in today's video you're going to learn about Python's iter built-in method, function. It's a function, not a method. So I would say the Python iter function is one of the most important Python built-in functions. So one of the top 10 to 15 Python built-in functions. So you will use it in a lot of projects, but probably not in all of your coding projects, such as other Python built-in functions are maybe even more important than the iter function. But I think it's still very useful to know about the concept of an iterator and how it actually works. So let's maybe open this up with a small graphic. So the Python iter function, let me make this a bit smaller. It returns an iterator. So the result of the iter function, there are two ways of calling it, and I will show you both ways in the code example in a moment. But the Python iter function, like in any case, it returns an iterator object. And what is an iterator object? An iterator object is an object over which you can iterate. So you can basically call the next function on this object. So you can call object.next, and then it will give you the next value of a sequence. And then you can call it again, .next, and then it will give you the next value again. And .next, the next value, next value, next value, until it returns a stop value. And this stop value, it's called like in Python, like in programming pattern language, it's called a sentinel object. This is the object, as soon as the sentinel is returned, you know that the iterator is now done. It's now finished. It has finished iterating over this object. Okay. So and it for an example is a list. So you can iterate over a list. So a list, like if you iterate over a list, it basically returns the next value, the next value, the next value, and then you can use it. And at some point you reach the final element of the list. Then the next function would return this final element, and if you now call the iterator again, there's no element left. The list is empty now after you have iterated over it. Actually, it doesn't empty the list physically, but like the iterator, over the list returns a null element or none element, and this would be the sentinel object. Okay, so this may sound very abstract to you, so let's dive into a practical example. Okay, so the easiest example is we have a list of some elements like Alice, Bob, Carl, Dave, Elena, and so on. Yeah, so we have a list of elements. We have an iterator. We call iter and pass the customers list into it. And now we can simply call print next iterator. Okay, so take a guess what would be the result of this code. If you run the code, the result is Alice. Okay, so it gives us the next element. Initially we start with the 0th position, so the next element would be Alice. So what if we like copy paste this and we do it again? Now the next output would be Bob, yeah, the second element in the list. Okay, and now this same, so if we copy this again twice, you see we have now all 4 elements, right? And so let's say we remove one, and now we iterate over the remaining elements of the iterator, and we do it like this, 4x in iterator. And now here in the initial example we have explicitly called the next element, the next element, and the next element, and then it gave us the next element of the iterator. But now we can also do it implicitly by using the in keyword, and you can iterate over all elements in an iterator. Yeah, I mean that's the purpose of it. You can iterate over the iterator. So you can call 4x in iterator, and this will then iterate over all elements in the iterator you created using the iter built-in function. And now we simply print x. So now take a guess, what is the output now of this code snippet? I can already tell you there are like two variants that may sound reasonable to you. The first one is you call 3 times you call the next elements, so you call Alice, Bob, and Carl, and then you go over all elements in the iterator. So the iterator is initially filled with our customers, so you print Alice, Bob, Carl, Dave, and Elena. Does this sound reasonable? No, actually it's wrong. This is not the way how it is done. Because an iterator, each time you call next, it is consumed. The element is consumed. Yeah, so you call next, the result is Alice. You call next, the result is Bob. You call next, the result is Carl. And now you go over all elements in the iterator. So implicitly it will just call next again on the same iterator on which you already have called next. Okay, so you call next. So the next result is Dave. The next result is Elena. So basically this code snippet will return all elements in the list, initially in the list. Okay, so but only once, not twice. And I mean, let's remove 2 of those next statement. What do you think is the result now? Take a guess. You can also comment before you move on with the video. So the result is actually exactly the same. Why? Because now it consumes only one element in the beginning, Alice, and then it iterates over all remaining elements. So now it prints Bob, Carl, Dave, and Elena within the for loop. Okay, so this is also the use case of an iterator. You iterate over an iterator, obviously. Okay, but now there's also this is one way of using the iter function by simply passing a list or another sequence into it, and then it creates an iterator out of the sequence. And the advantage of using an iterator is that it doesn't have all the elements. It doesn't need that you create all the elements in advance, like in a list, for example. Here, if you create a list with 1 million elements, the list will reside in memory. So you will have in your Python memory, you will have a list with 1 million elements, which can or 1 billion elements even, which can really quickly populate your memory with a large number of elements. But if you use iterator, actually it doesn't. It just uses a pointer. It just needs to implement the next function. So it doesn't actually create a whole list over which to iterate. It simply creates one element at a time, which is much more memory efficient, and then it can throw away all other elements. Okay, so it just has a pointer to the current position in the list, like position 0 initially, then position 1, position 2, position 3, and so on. So the implementation is usually much more memory efficient if you use an iterator this way. Okay, so let's have let's go dive into the second use case, which is quite interesting, I think, and many people don't know this. So first, let's import the random function, and now we create a function def roll dice, and the function doesn't take any argument. It simply returns a random integer between 1 and 6. Yeah, so it's all it does. So for example, you can call roll dice, and then it will give you a number. Random rand int. Okay, like this. So let's run this. Now you see the result is 1. So let's roll the dice again. Okay, 1 again. Rolled again. 4. Okay, so now we have some random elements here that we create with the function roll dice. And now we can, out of any function or actually any callable, so any object in Python that you can call, for example, functions are callable, any function can be used as a basis for a new iterator object, and you can use it for example, you can iterate as long as an element is returned that is not a sentinel element, right? I have already explained the sentinel element in the initial example. Here you see you actually call the function next until it returns a sentinel value. This is how the iterator is implemented, and you will see an example in this moment. So we create an iterator, so let's call it my iter, and now we use the second way, passing a callable and a sentinel. Callable can be our function like roll dice. So now instead of implementing their own next method, like for example in the list example or so, where it probably internally just has a pointer to the next index in the list object, we explicitly pass a function that should be used that should be called each time we call next. It basically now simply calls this function object and then returns the return value of this function call. And now we have a sentinel element, like for example could be 6. So now we want to we roll the dice until the dice returns the value 6, and as soon as it returns 6, we finish. So the iterator is considered finished and is considered empty. So we have iterated over all elements. Now this is an interesting example, isn't it? Because now you can do the following for x in my iter. So you can iterate over this iterator. We simply print dice roll, and we print x. And now at this point, yay, we print yay dice roll. So what do you think is now the result? So if you reach this point in the code, what was the final dice roll? Yeah, it was 6. So it basically it repeats. It's calling this. So internally, here in the loop, you don't see any call of the function next. You don't see the call of the function roll dice or so, but it actually calls. I mean, the iterator myIter is defined as an object that calls roll dice until it returns the sentinel object 6. So it calls the function roll dice again and again and again, and at any point it will return the value 6. So the random value 6, and in this case, it will the iterator will be considered empty. And as you iterate over this iterator, it will then go to this position in the code. So if you are at this position, you can be sure that the dice roll was 6 at some point. So let's run this example in the code shell. Okay, so now you see we have like 4 dice rolls until we reach the value 6. Like first we called 5, then we have 2, then we have 4, and then it actually reached the value 6 and it left the loop and it terminates the program. Okay, so you can run it again and it will have some different results because we use the random library, so it randomly chooses some numbers. We can call it again and we will have yet another result. Okay, so this is also a very interesting use case, and you see you can create your own iterator based on any function that simply has some return value. So basically any callable, any function you can call also has a return value. If it doesn't explicitly define a return statement, it will just return none. So you can, on any function, you can create an iterator, but it will only make sense in functions that actually return a value. And probably it should also return a different value each time you call it. Otherwise, it will like either never reach the sentinel value, or it will trivially reach the sentinel value in the first function call. In both cases, doesn't make a lot of sense. So it should return a different value each time you call it, or most of the time you call it, or there should be some randomness, either randomness, or it should be like some partial computation that it returns or so. And then you simply call this function again and again and again in your iterator until it is considered empty when it returns the sentinel value. For example, in our case, the integer value 6. Okay, so this is everything I think you need to know about the iter function. I hope you learned something out of it. Thanks for watching this video, and see you in the next video. Bye.